Alright, so now we are going to be just doing a bit of physics, okay? So what's the first thing you need to know in our physics? You need to know what speed is. Speed. Probably know what speed is. You're just going the car speed. Also know what velocity is. Velocity and speed are the speed is movement without a direction, and velocity is movement with a direction. So, how do we calculate speed? So, speed is equal to distance over time. So, you can use this to calculate speed. Speed will always be in meters per second or kilometers per hour. That's speed. The average speed will be total distance traveled and total time taken, okay? Now, yeah, understand? Okay, now we're gonna look at a graph, which is gonna be a distance time graph. Now, how are we gonna look at speed? So it's gonna be time on the x-axis and distance on the y-axis. So, let me just make a rough sketch. So, here distance time graphs are not too good, but like let's look at them. So if it's curved, that means there's acceleration. And if there's a straight line, that means there's a constant speed. The thing is moving at a constant speed. And if it's still like this, that means it's not moving. However, there is an exception. If it's a flat line like this, then it could be just going around the roundabout from where it's being measured. And now, how are we to measure acceleration, though? That is the question. So there's another formula. What? So acceleration is A equals V over delta T. V here is velocity and T here is time. Now this is delta, meaning change. So that's acceleration. Acceleration, when you're changing speed, going faster. And if you're becoming slower, then that is not deceleration. It's better if you call it a negative acceleration. Also, for speed, it's v equals s over t. S over t. There's also speed time graphs. This, instead of distance, uses speed, you probably have guessed. So you'll have your line. This is speed. This is time. So here, if it's a straight line, then that is acceleration. That's acceleration. If it's uh, like a parallel line to time, then that means it's traveling at a constant speed. And a curve, sort of hard to explain, it symbolizes a change in the rate of acceleration, if you catch my drift. It's, yeah, it's a change in rate of acceleration. So, how here in the distance time graph, calculating the distance was pretty easy. You could literally just look at it and you can pretty much just find the distance because yeah. But here it's a bit more tough. We can't find the distance if there's a curved section. The distance is found by looking at the area under the curve. I mean under the graph. You can either use a trapezium formula or you can divide it into triangles and a rectangle. Then you can easily find the distance. Then the area is the distance. Also, the unit for acceleration is what is the unit for acceleration? Let me just bear with me for a second. It is m divided by s squared, or ms negative 2. Or if you're weird, then it's just m by s by s. That's acceleration. I think that might be it. There's also ticker tapes, which is just like a machine used for acceleration. You don't need to know that. This contributes to my plant stuff because it shows how much a plant grows. So, yeah, I think that's it. That's for speed. That's all for speed. Thanks, guys.